we're going to find a way to use carbon dioxide removal to do something else. It won't be its only activity. So we're going to take CO2 out of the air while accomplishing something else that society needs. And in doing so, we're going to dramatically reduce the cost of carbon dioxide removal. We're going to drive it down from being its own functioning thing to actually an input into other processes in order that it can be much, much, much cheaper. That was sort of the aha moment, the insight that sort of led to the rest of what we do. Put those two things together and you end up with the basis for what Capture6 is doing.
So welcome to this week's Leaders on a Mission. I'm your host, Simon Leach, and we've got a great show for you today. And, let's start with this one. I mean, to meet our climate goals, we don't just have to cut emissions, right? We have to pull billions of tons of CO2 out of the atmosphere, right? And, we've all seen and read and heard about all this kind of carbon removal, and scaling it isn't just a scientific challenge, right? It's an economic one. And yes, the beauty of this show today, right? I'm joined by Ethan Cohen Cole, who's an economist turned founder and CEO of Capture6. Now, Capture6 are a company pioneering a really interesting, radically integrated approach to direct air capture. The show today, we're going to dive into the economics, the infrastructure, the innovation intersect, and really delve into what it takes to build a real scalable climate kind of solution. So, Ethan, thanks so much for coming on the show today.
Thanks for having me on the show, Simon. Pleasure to be here.
I'm glad we got there. We've been talking about it for a while, and what I found really interesting from our conversation, I've had 140 odd episodes on leaders on a mission. You're the first PhD in economics I've had on the show. And
have you been avoiding us?
I think I probably have. And I'd love to understand a little bit more about your personal journey and path that led to you founding kind of Capture6, as it were, and particularly what sparked your transition from economics to climate innovation.
I appreciate it, Simon. And you really should have some more PhD economists on the show. We have a lot to offer out there in the world. I just had to put a plug in for the industry. Climate's always been a priority for me. For various reasons, I ended up doing a range of things before I got to this. I was a finance professor for a while. I worked as a bank regulator. And ultimately, I founded and built a consulting company that worked on economics and finance. When I ultimately sold that company in 2019, I had the time and space to focus on working on what I've always been passionate about, and now was then able to focus on the topic. 2019, I handed off the company and then had the opportunity to really dig in and try to figure out the solution to what ultimately became Capture6.
So tell us a little bit more about how did you come across it? And because you were the co-founder, right? One of the co-founders, right? So
I was one of the co-founders. And Capture6, I think, unlike my last company and unlike some other things, came about by trying to think through systematically what the big problems were, and what within that set of big problems, and there's a lot of them, what could I contribute to? What could I actually have some impact on? And the space of big problems is really, really big, and I'm unable to solve, I would say, the vast majority, if not all of them. And within that, I was looking for both defining what the problem was and what the big issues and the ones that sort of would be transformative to society if we were able to solve them. And then within that, what it is we could actually contribute to. So what were the big problems that we were trying to figure out? And ultimately in that thinking process was carbon removal was this intractable problem that we kept coming back to. There are lots and lots of problems again, right? We need many, many more renewables out there in the world. And to be honest, lots of people are solving them and there are solutions to it. And I didn't feel like I could contribute that much. More solar panels, wonderful. It's really important. We have to figure out better solutions. And that wasn't my ability to contribute in that space. Carbon removal seemed to be the problem that required a significant amount of change, both to how the world thinks about its processes, the costs associated with doing it, and sort of the economic, political, structural problems and actually going from a fantastic idea, meaning we need to take carbon out of the atmosphere, to deploying in a functional way that gets us to the endpoint. And so we ended up focusing on that topic. I say we, a lot of the thinking process that I'm talking to back in when we were conceptualizing this, I spent a lot of time with one of the advisors on our to Capture6. A lot of time in his backyard, a lot of time talking to him on the phone, trying to figure out how to come up with this particular solution, and that solution that we now have, that's now Capture6. I don't know. I could talk more about it, but let me know if I'm going in the direction that's helpful.
Yeah, I mean, yeah, let's dive into it a little bit, because it's a unique solution. So it sounds like you guys were really kind of scratching your head and kind of going through, kicking the tires around in order to kind of come up with it, as it were. So tell us a little bit about the solution and, what you guys do, and particularly, as it relates to how you kind of compare, contrast to other solutions,
Sure. I guess that's a good place to start. As we thought about what the big problems were, we spent a lot of time looking at, let's call it, other solutions or the industry more broadly, and trying to understand, why is it so expensive? Why is it a challenge? What's not working? And that came down to a few things that we identified as core problems that maybe could have some solutions associated with them. So first, think about carbon removal and how it's done, at least from an engineered carbon removal perspective. And when I talk about carbon removal on the show, I'm mostly going to talk about engineered carbon removal. There's also a whole set of solutions around nature-based, growing trees, other sorts of things that involve nature that are fully separate from what I'm talking about today. So I'm just not going to talk about them very much. On the engineered side, effectively, engineered carbon removal works as follows, and then I'm going to talk about how we adapted or changed it. But the baseline idea behind engineered carbon removal is that you take some substance, whether it's a solid or liquid, that has some property to it. Normally that property is it's got some alkalinity. It's got something in that substance that allows it to bond with carbon dioxide. So it allows it to attach to carbon dioxide. Whether that carbon dioxide is in the air or a smokestack or something else, that substance will bond with carbon dioxide, and as a first step. So as you imagine, it sucks it out of the air and attaches to your substance. The second step for the vast majority of carbon removal companies then is you've now got your carbon dioxide attached to the substance that you were using, and you have to separate the two of them. And separating the two of them almost uniformly requires heat. So you heat up this thing, this combined thing, and it separates out the carbon dioxide for you. Now you take the carbon dioxide in the form of a gas, you have this concentrated carbon dioxide now, and you go put it somewhere. You store it, put it away, and you've now removed it from the atmosphere. And you have your original substance that attaches to carbon dioxide, you get it back, and you repeat the process. And so you have this looping process, which can be quite elegant, because you started with something, you attached the carbon dioxide, you removed it, and you're back to the beginning. And that's a fantastic idea, and it has a few fundamental problems with it. The first fundamental problem is that it requires a lot of energy to accomplish this. So first you have to make the substance. Somehow you got to buy it from somewhere. It's expensive and requires energy to do that. And the second step requires a ton of energy, which is to separate out the carbon dioxide from your substance after you've captured it. When we saw those models, that was the first thing we identified. That is, how does this work? Oh, it takes a ton of energy to separate these two things out. And maybe we've come up with a way to solve that. So I'll come back to how we solve that in a second. The second fundamental problem with this carbon removal process is that it's only doing one thing. It's removing carbon. So it goes around and around and around in a circle, and it only does that. It removes carbon. So when we look at those two things together, it uses a lot of energy and only does one thing. That's been the subject of quite a lot of criticism broadly in society. You say, well, we're going to spend a lot of energy, the order of magnitude, maybe of a tenth, a quarter of all the energy in the world to take carbon dioxide out of the air for only that purpose. And that means it's very, very expensive and very energy intensive. So how do we deal with this? So our solution, and the intro to the inspiration and the pathway of the solution, is we have to solve both of those problems. We have to have carbon dioxide removal do something other than just take CO2 out of the air. And two, it has to not require so much energy
Yeah.
cost together. So we so-called unbundle it. We're going to find a way to use carbon dioxide removal to do something else. It won't be its only activity. So we're going to take CO2 out of the air while accomplishing something else that society needs. And in doing so, we're going to dramatically reduce the cost of carbon dioxide removal. We're going to drive it down from being its own functioning thing to actually an input into other processes in order that it can be much, much, much cheaper. That was sort of the aha moment, the insight that sort of led to the rest of what we do. Put those two things together and you end up with the basis for what Capture6 is doing.
Yeah. Got it.
So our solution, I can move into that if you want, or I can talk more about the sort of the formative process about how we came up with this.
No, that's great. But yeah, no, tell us a little bit more about the additional solution, as it were.
Sure. So once you unbundle carbon dioxide removal, so to speak, and you say it's no longer going to be a little loop in which you go around and around in circles. So now you have the question, this is how you're going to do carbon dioxide removal. Remember the core steps. I need something that attaches to CO2 from the air or from the smokestack. And then I need to do something else after that. I need to separate it out or do something else. So if you need something to capture CO2 from the air, smokestacks, you either have to make it or buy it. That's true of everything else in the world. You're going to make it, buy it, do something. So we're going to make it. And to make that substance, we want a input, a feedstock that's as cheap as possible. So if you can make something from something else for free, that's great. Even better if you can make something from a product that somebody else doesn't want, then it's even better because they're going to pay you for it. So ultimately what we're going to do is we're going to make our carbon dioxide removal substance from plain salt. And as it turns out, there is a massive amount of plain salt that people don't want in the world. It's typically mixed in with disposed of brines, waste products, things all around the world, from desalination, from human wastewater. Those salts exist in all the things that society doesn't want. So we're going to take that waste product and we're going to use it to capture CO2, to create the solvent we need to capture CO2. And when we're done, we're going to avoid that critical heat, energy intensive step of separating out the solvent from the CO2 because we're not going to bother doing that. The CO2 is going to be mineralized into our solvent and we're going to leave it there. And so through the process, we end up with revenue enhancing components, which are associated with this disposal that nobody else wants to deal with. And two, we're going to dramatically reduce costs by getting rid of the section of that carbon removal process that's costing everybody else so much energy and cost. Perhaps most importantly, that entire process becomes something that's not a single use or single function process. It actually carbon removal becomes a way to accomplish other things in the economy. In this case, cleaning up somebody else's waste, and I could talk more about it, also produces fresh water and enables us to engage in the economy and remove carbon as like a business function rather than as its own sort of circular process.
Yeah. How does it make the fresh water then? How does it contribute to the fresh water?
Sure. So let's go back to that waste product that I talked about as our feedstock. And you can think about the back of a desalination plant. So I'm going to take in water from the ocean. That water from the ocean is about 3.5% salt. After it goes through the desalination process, you get some fresh water from the desalination company, and they end up with a waste product that's about 7% salt. So that 7% salt solution that they would otherwise throw back in the ocean or pay to dispose of is only 7% salt. Now, we want that 7%, but the other 93% is fresh water. So we're able to take a lot of that remaining 93%, extract it out and put it into the consumption water supply, and then use what's left over as ours to make our solvent. That 7% portion is what we could then use. So we're generating a whole bunch of extra fresh water on top of what the desalination plant was doing while we do our process of capturing carbon dioxide.
Right. No, I love it. I love it. Now, tell me, put your economics hat on. I've read quite a lot of stuff. I think the carbon height, as it were, in terms of some of these technologies over the years, right? Everyone got very excited. And, I think I've read somewhere the cost per ton was roughly between, I don't know, $500 and $800 a ton for direct air capture today, right? And I don't know where we need to get to for it to be kind of meaningful, but how does the economics work with your technology?
Your numbers aren't terribly far off. I think there are um, actual transactions and costs could even be higher than what you're describing uh, for most of the direct air capture processes that exist right now. And that's indeed sort of the fundamental thing that we were trying to solve. Let's talk about that in two ways. One, the existing direct air capture companies have both been inspirational to us because they've achieved many things so far. And two, they will announce now that when things are good in the future, that price could come down. So the cost of their production and the price of the sale of their product can come down. And they talk about in the future that perhaps it could get to $300 a ton and maybe even lower, maybe even at 200 or in some very optimistic scenarios lower than that. Even in the most optimistic scenarios, those processes have a fundamental flaw, which is that they are one process that somebody needs to pay for to remove CO2. And it doesn't take much math to figure out that if we need to remove, let's say, 10 billion tons a year of CO2, that's a lot of money. So, and it's unclear who's going to pay that enormous amount of money to remove 10 billion tons of CO2 at those prices.
Yeah. Yeah.
So even in the optimistic scenarios, this is a challenge. What Capture6 does is turn that model on its head. Now we use carbon dioxide removal to make other processes better. So when we process brine, we process it for lower cost than our client would have processed it for otherwise. So in Southern California, the folks at Palmdale Water District have identified that we're saving them 20 to 40% on their own brine processing costs. We'll also be saving them on their water acquisition costs. You put those two together, and the implication is that carbon dioxide removal can facilitate other things rather than being a cost center in its own.
Right. Okay.
And that's a fundamentally different model about how we think about decarbonizing the economy. It could actually do effective things other than its own functionality out in the field.
Yeah, no, I love it. Absolutely. And what's the key to getting the economics kind of working now? And because I mean, this is a fantastic innovation and idea, right? It's about, and I know you've got projects in play, but it's about how you kind of start commercializing this, right? And start bringing this out in the world, right?
Well, I think there's a few different things. I think there's both the principle and the philosophy that I've discussed, and there's also how Capture6 can succeed. And I'll talk about the principle and the philosophy first, because it's part of what motivates me. That is, carbon dioxide removal can be used for other things, and I think it can be used for other things in business models that are not mine, that exist in other companies, and to solve other problems. And I would like and believe that the industry can solve these other economic, social, et cetera, problems that have existing markets, and that could enable carbon dioxide removal to scale and grow much, much more quickly. So the first and the hardest part, I believe, is changing how we think about the function of carbon dioxide removal. And once we accept that carbon dioxide removal could achieve these other things, we're not trapped in this model of having to rely on the voluntary carbon markets or on other people's benevolence to grow. Part two, we think we have a compelling solution at Capture6 that solves a particular economic and social problem. Solving the billions of tons of waste brine that are generated every year is a social problem that causes environmental hazards around the world, and is currently an existing $1 trillion market. Two, providing fresh water solves existing problems in water scarce areas. There's also an existing $1 trillion market. We're targeted on solving and helping in those markets because those are existing places where we can sell our goods. Capture6 scaling and growing. Yes, it's incredibly hard. I will not pay the notion that growing a company is hard, and we have lots of work ahead of us to deploy and get basic things right. I will highlight the basic things right because while basic things can be very, very hard, they aren't fundamental problems around does air capture work? They aren't fundamental problems around, scientific achievement, or can the cost change in the future to some level that can make society work? They're very much real world business problems, which is, do I get enough clients? Can I get my engineering team to function properly? Can I buy the goods at the right price? Can I, you name it. These are problems that people have been solving around. And maybe Capture6 will succeed at that, and maybe we'll fail. I hope it's the succeed version. Don't get me wrong. And I hope if we fail, though, that somebody else deploys the same general ideas about making carbon dioxide removal effective and influential in the economy, aside from its own functionality, happen. Because that would be because our company didn't succeed at the basics, not because there's something wrong with the principle. That's quite straightforward.
Yeah. The strategy and the actual business model itself,
That's right.
Yeah.
Right. It is quite possible to use carbon dioxide removals to facilitate other economic ends. We should be doing more of that. I have a particular business model, a particular team, and a particular set of contracts that I hope are successful, and we'll grow and do more of those. But that's very, very different than the philosophical portion and the business model reconstruction that I think is independent of Capture6's success. But I'm a big advocate for it.
Yeah, no, got it. Just one thing technically, and then I'll move on to other things. When you've got the solution, the CO2 kind of capture within, the mineral, as it were, can you not deploy that as a feedstock for certain industries and sectors, as opposed to
Of course.
Yeah, and is that part of the plan? For
our plan. So there's a few things. The short answer is yes. There is a demand for the pure CO2. Actual, you put it in beverages, and some people are injecting it into cement to make it stronger. I understand, not my field, but I've heard that that's also something that's happening. I know that the oil industry uses it to extract more oil. That's a whole separate conversation, but it's indeed another use of CO2. The total amount of that CO2, though, that's used in industry right now is much, much, much lower than the amount of CO2 that most scientists think we need to extract from the atmosphere.
Yeah.
Okay. Part two, our business model does allow us to sell pure CO2, and it also allows us to take the embedded CO2 that's been mineralized and store it, and or sell the ultimate product, which comes out as a carbonate. We can sell that ultimate product. So it's quite possible to use the outputs of this process, but I do think we have to accept that at the very largest scale, it will require us to meet climate goals, requires actually to store the product in some way.
Yeah.
I could talk more about how we do that. I think it's innovative, but ultimately I think from a climate perspective, we can't solely rely on industry to use the CO2.
Yeah, got it. What really strikes me about, your background, and you spoke about it like before this journey with Capture6 and now, what you're looking to do, it looks like a vastly different journey, right? In terms of being in the space where it really kind of matters to you and you really kind of care about it. But how have you found kind of the journey of a CEO, kind of founder of a very innovative, I suppose, deep tech kind of engineering kind of innovator in this space? How do you kind of resonate with that?
Back at the beginning, you asked some questions, and my answer was, as part of the goal for finding a solution was that it had to be something that me and my team were able to do. And so part of what we attempted to do was come up with a solution that would reduce this problem away from as many sort of particular scientific challenges as possible that we were unable to solve. So if you say, I need a better membrane, that's kind of not what our team's going to be able to do. However, if you say, can you deploy an economic and business model that improves upon what's being currently done, that's a business and economic set of questions that we feel quite capable of deploying. Now, of course, once you're doing that and you say, well, I need to build this facility, I need to hire a bunch of engineers that know a lot more than I do about how to, make a reverse osmosis machine work or connect a bunch of shipping containers. That's fine. And there are people who were quite skilled at doing that. But the business model we built was based on solving those things first, meaning the big economic problems, the contractual problems, and reducing as much as possible the particular scientific challenges around innovation that wasn't my background, right? So we patented the general process. We patented a whole bunch of other smaller things within it, but we wanted to solve the problem for that we knew how to solve, but also because we believed that particular set of problems, there's easier and more accessible expertise to enable it to scale much more quickly. So if you say, I have a new membrane, I've got a gazillion new problems I have to solve to go from one membrane to a million membranes to deploying them, etc. If you say, I built one house, I want to build 100 houses. You know what? People already know how to build houses. You show them the blueprint and you say, build 100 of these. Now you have a scaling problem around, could you buy the wood cheap enough? Could you get the right contractors there on time? But those are problems that many, many other industries have solved. And we don't need to reinvent the wheel on how to build a house in order to solve the climate problem.
Yeah.
We need to solve other things. So we've created a blueprint that can be scaled quite easily because those are technologies and approaches and systems and people that already know how to do that. Oh, one blueprint, I can make 20 of those, no problem. So that was ultimately our goal. And as a result, then I drew on my background in running other businesses and being an economist where we're not solving something new there. We're deploying and we're solving known problems. So get over the original hump, solve known problems after that.
Yeah, I got it. And tell me, I can't remember exactly when you closed your last. It was a significant funding round, relatively recently. And I'm thinking about the last 3 or 4 months, beginning of the year, right? Okay.
Yeah.
And what? Yeah, I mean, for you, like when you think about the next couple of years, what are those main milestones from where you are now to the next couple of years? What's ahead for you?
It just talked about a minute ago, the idea that you have a blueprint and you build and then you can replicate pretty easily because it's known methods. That's been core to our philosophy. And as a result, now when we think about the next couple of years, it's deploy, deploy, deploy. We have things coming shortly. Those will be in the blueprint of that repeated succession and growth. And we have to execute now. And ultimately execution is hard, but it's straightforward. So we have a lot of straightforward execution to do now over the next couple of years.
Awesome. Yeah, because so you're not solving technical challenges per se, and it's just literally rolling out and creating the kind of the right kind of partners and deals essentially with this technology, right?
That's the goal, and that's the business model. Everything always has challenges, don't get me wrong.
Yeah.
But the goal here is to minimize the complexity of those challenges so that we can roll out something that's well known, understood, etc. So over the next couple of years, execute on our building projects, execute on the partnerships, and build the relationships that will enable us to go from, one blueprint to 50 to 500, etc.
Got it. Okay. Yeah. And because I've noticed that having a look, you've got 4 or 5 projects, I think, underway at the moment. It's documented on your website as well. They seem very international in scope. So is that how? Yeah, give us some view in terms of where you're really seeing the opportunities for the business.
What we found is that this approach, this blueprint, so to speak, can work effectively anywhere in the world. That is, we're not specifically dependent on tax credits. We're not specifically dependent on a particular weather pattern. Where it works best, we have somebody with a waste problem. And as we found out, that waste problem, from human wastewater to desalination plants to industrial wastewater to produced water, exists everywhere. We have not found a location yet that does not have a wastewater problem, again, in the billions of tons a year of this waste. So part of the philosophy originally was both diversify internationally to minimize against political changes and risk, and 2, to diversify to demonstrate that this could work in all these different locations. And that strategy has so far paid off. That is, we've seen changes politically in the US and other countries as well. We've seen upheaval and changes in different places. And our business model will continue both in those places as well as in others. And that's been core to what we're trying to accomplish.
Yeah.
So over the next few years,
Yeah.
hopefully it expands to other locations as well.
Yeah, got it. And that means like with the, with the Trump administration and all the kind of challenges it brings as it relates to support for, I suppose, this industry, right? It sounds like, yeah, well, what have been the effects of someone like Trump coming back in for you guys?
So the philosophy again is that the carbon removal should be able to handle and deliver solutions in other industries and enhance those solutions. It means this is a positive business model independent of whether or not governments are supportive of the industry or not supportive of the industry, meaning the climate industry broadly. And we built it to be resilient for that reason. We didn't anticipate Trump. We didn't anticipate particular changes in the climate policy. But we knew that our infrastructure facilities and these projects needed to survive whatever happened. And that speaks again to the approach that you can't be dependent on the voluntary carbon markets or on government support. We think those government support, as we have some in California and Australia and in New Zealand, is very, very important because it helps sort of launch new companies and launch industries. But we've been focused on having the company be independent of those changes so that when or if things happen, then we can thrive regardless of the environment.
Yeah.
Specifically, we haven't been negatively affected.
Yeah.
Right.
Yeah.
And in part because of the nature of the business model we built.
Yeah. Yeah, no, got it. And tell us a little bit about some of the projects that you're working with. When I'm thinking about deploying this, I'm thinking, how long does it take? How much capex is involved? What are the key kind of things you need to unlock in order to execute on these projects successfully?
It's an interesting question because I'll again put it in the context of make carbon removal helping other industries. So if you think about it that way and you say, well, I can solve somebody else's brine problem, then I don't actually need new capex for my facility because that capex was going to be deployed anyway to solve the brine problem that they had anyway. So in Southern California, the Palmdale Water District was going to spend money building a 70, 80, 100 acre brine pond. And that was significant capex that they were going to have to deploy. Instead, they're going to be spending 20 to 40% less in order to facilitate the production of our facility. So in that sense, we don't actually need new capex. And that is another fundamental difference between us and other companies. On a practical basis, we always raise money because, of course, somebody has to pay for the facility. And so we have to work, for example, with the Palmdale Water District on the sources of that capital. But it puts us in a very different position from having to uniquely identify we need $1 trillion for carbon removal. In fact, the world needs lots of money for water and brine projects. That's the same as it needed yesterday.
Yeah.
In fact, it probably needs more than yesterday, but not because of carbon removal.
Okay.
Right.
Absolutely. And what is the environment then? How are you finding the environment as it relates to, to this? I know the position you mentioned here, and it's great, but how are you finding the appetite to invest in these projects right now and to move forward, as it were? What's the environment like?
It depends on where you are, who you're talking to, and what kind of project, as always. We find that there's a new government in Korea that is really motivated to invest in climate projects. The Australian government is very motivated and a huge appetite for new water projects. California is very motivated to solve water problems, particular inland water and brine challenges has remained very large in California. It's true in the Middle East as well. We certainly see some increasing skepticism in the US about funding for climate projects. We haven't directly been exposed to that in the sense that that skepticism at this point has been around projects that are not ours, right? Wind projects, right? We're not building a wind project or a wind farm. And so we're navigating this mix of emotions and opinions from around the world. And I'll point back to the business strategy and the diversification that you brought up. That's exactly what we designed the company to do. That will be unchanged in a few years, meaning who knows if the Koreans change their mind and are no longer motivated, or if we have a new administration here that decides it wants to fund things. Our goal is that to the extent to which people need water or to solve their disposal problems, we can provide an economic service to them.
Yeah.
And that's, we found to be pretty immune to political changes. Nobody wants to be the politician that says they're going to cancel the water service or not invest in clean water for the community. That sort of doesn't go away.
Yeah. Yeah, absolutely. So where do you think the dream is then, like now, when you think about, like what you've got ahead of you and what you're really you feel that you're able to the impact you're able to make with this?
I hope that the technology and the approach can provide a lot more water, solve much of the water waste brine problems that we're seeing around the world, and as a result, dramatically scale carbon removal. That this negative emissions approach could have a significant positive change, negative carbon on the climate and on our ability to deploy these solutions, because they could be done on the backs of the very, very large demand for these products that people need to free forever and will continue to need forever.
Yeah, awesome. No, thank you. Well, you must have hundreds of people working at your company with some of the projects or work that you're doing, I would have thought.
Part of the idea here is these need to be efficient. And yes, there are lots of people working on these projects. Our core company is only about 20 people.
Right. Okay.
We end up having engineering teams working for us around the world on these projects. And as those projects roll off, different people are hired in different places. But the core team is only about 20 people.
Got it. Really? Wow. Well. It seems like it's interesting, just like you're literally around the world, your kind of knowledge on kind of geopolitics and governments and kind of challenges on water. And I mean, it's pretty broad. And, it's obviously a small niche team, as it were. And what's it like to work with Capture6 then? I mean, what kind of, tell me a little bit about the culture and the people that work with you guys.
Good question. I think we have found a truly fantastic group of a couple dozen people. They are, I think, to the individual, highly motivated to see our solution deployed, care about sort of why we're here, both from a climate perspective, but also from a sort of desire to build a real tangible business. And that's very satisfying. I've run other companies before, and sometimes you get people there who are punching the clock, who want to make a check and go home. And we've been really fortunate to come across the team we have now that's to the individual, highly motivated and excited to be part of the team and the effort.
Yeah, sounds like a great place to be. And look, it's been fascinating having you come on today. I really appreciate it because,
thank you, Simon.
This has been a really innovative, what you're doing, your approach, the business model, the blueprint, it's super ambitious. It's super ambitious. It makes so much sense, just the way it's such a unique approach of how you're thinking about kind of carbon removal and how you can create an economic, positive kind of business whilst solving these kind of challenges as well. So really appreciate you coming on and sharing the journey.
Thank you so much, Simon. I appreciate it. Thanks for having me on.
No, it's a pleasure. And to all the listeners, hope you enjoyed the show, and we'll see you on the next one.